electronic book online. You know that, right? Yeah. So it's in there. You don't have to go through the folders. It's one of the folders. So yes. Okay. Most important thing here, the assignment on this for this day would be our day 1 and cross out the book assignment. I'm just going to do the worksheet. And I'd be writing my own book. Yeah, probably better chance. Okay, so we're going to do slope fields, but first we're going to start with this opener, and we're going to solve a differential equation. Now, remember I said you had to know what a differential equation was. Do you guys know? Yeah. Without looking it up. And we will pause for a moment. Yes. Okay. What is a differential equation? I've had a lot of time to think about this, right? It's an equation involving derivatives. And the reason why you have to know this is because you're going to have a differential equation, and they'll say solve the differential equation. Kind of nice to know what they're talking about. Involving derivatives. And when you solve an equation, what are we looking for? Derivatives. Are we looking for numbers?
No. Yes.
Whose solution is a what? Is a function. Okay. So let's solve this differential equation. I'm looking for a function that if I put that in there, it makes it true. Now, I like to do this correctly. I know the book just integrates both sides, and that's fine. However, when we get to more complicated ones, like the one you saw up here, we actually have to know how to solve it by multiplying q by the dx. So dy is equal to 1 over the square root of 1 minus x squared minus 1 over the square root of x, and we multiply that by dx. And how do we undo a derivative? We integrate. So what's the left side going to give us? I don't see my integral symbol, but 1 what? 1y. This tells you the variable. But where z would be a z then. So it's y equals. Now, do you know what this integral is? And somebody said it was in the homework. I'm going to break it into two integrals. And I'm going to have a little problem with the other one. Well, all I know are these. The integral of x to the n is what? X to the n plus 1 divided by n plus 1. There's one problem with that rule. Because when n equals negative 1, what happens? I get division by 0. Can't have division by 0. So we have to exclude that. So then we have to know this. What happens if n is negative 1? That's 1 over x. And somebody said it. It's what? Yep, it's the natural log of the absolute value of x plus c. And there'll be a time when I will talk about y's absolute value a little bit more. Okay, so how am I going to do the square root of x? 1 over the square root of x. This is all I know. I have to make all my antiderivatives, where I'm looking for them, look like the power rule, or 1 over x. That does not look like 1 over x. It's 1 over the square root of x. Can I write it with a negative exponent? Can I write it this way? And then I can use the what rule? Power rule. Okay, so that one, once I see that I have to rewrite this like this, it's easy. What's the other one? So that's why I'm gonna give you that list of functions and their derivatives, and you're gonna have to know them. This one, this is, I rewrote 1 over the square root of x is x to the negative 1/2. But you gotta ask those questions. I'll give you a hint. The other one has to do with trig. Oh, it's so close. Actually, that would work. But because it's positive, I'll do an inverse sign. Good job. Okay, guys? This is, it's kind of low-key today. It's okay. Inverse sine of x. What's the antiderivative of x to the negative 1/2? Look empty.
I didn't know that was that one.
Oh, yeah.
That's pretty cool.
What's this going to be? X to the what?
Wow, negative half.
Go up 1. 1/2. Divided by 1/2 is the same as times 2. They both have constants, but we'll just call one constant because who cares?
Isn't it
I always miss somebody.
divided by negative half?
No, we add 1 and we divide by 1/2. Well, dividing by 1/2 becomes multiplying by 2.
Multiply by
Do what? This is. It's right here. This one belongs to this one, and this belongs to this one. And they both have constants, but I'll just call it C. Guys, I can't hear them. What? Oh, it doesn't matter. It's just a constant. It doesn't matter. Okay, so let's look at a couple of problems out of the homework that I forgot to assign you. It's inverse sine. The derivative of the inverse sine is 1 over the square root of 1 minus x squared. You could also do this if you wanted to. You could have said it was inverse cosine, but it would have a negative sign with it. These are the same. I know it's crazy, but... And then we had a whole list of derivatives. I don't know what color it was, but yeah. I will make more copies, and maybe we'll do that on Monday. Because Monday we're going to do the chain rule. How are we going to do with the chain rule? I don't have any composite functions here. Well, I will if I do some of these problems. So the class asked me about number 4. So let's look at number 4. This is 6.1 homework that I forgot to assign. I assigned 1 through 4, and the quick review, 1 through 11, just the odds. I kept it real short. We don't like this assignment particularly because it's kind of hard. You know, they don't give you some nice problems to practice with. They throw hard ones at you. This is very similar to what I just did. And they say x is bigger than 0 because x can't be 0. Okay? X could be less than 0, but they did restrict our domain. So, Jack, what's the antiderivative of 1 over x? That's right. ln of the absolute value of x. First, I'm going to set it up because when we get to the complicated problems, we're going to have to worry about it. So we're going to integrate it. Oh, that's good. So what's the antiderivative over here? Y equals, and then this is the natural log of the absolute value of x. Okay. Now, how are we going to do the 1 over x squared? It's the x to the negative 2. No, it's the power rule. You always, any power, you always want to make it. No, because why can't we have x to the negative 1? Because it would be dividing by, remember what happens when you put negative 1 in?
That'd be 0.
That'd be 0, because you have to add 1. And you divide by that exponent, so you'd be divided by 0. Yes, if you can remember that, you shouldn't make a mistake. You'll always get your log there. Okay, so y equals the natural log of the absolute value of x minus, and I just rewrote that as a power, even though it's a negative exponent. So it's x to the what? What's this one going to be? Negative 1 divided by negative 1. I could cancel the negatives out. If it's free response, don't do it. No, because it's not right. If you take y equals 3 over x cubed, I'm going to rewrite that because I don't want to use the quotient rule. And now let's take the derivative. dy dx, how do you check? You take the derivative. Negative 9x to the negative 2. do it right? I could be going the wrong way. Jake. That's right. This symbol together with this means find the antiderivative. Jacob's saying it disappears. It's like saying the square root of 9 is 3. What happened to the square root symbol? It disappeared too. It's an operator. You used it up. It's the same as saying you have 2 plus 3, and you don't go plus 5. You say it's 5. Does that make sense? It means add them. It's telling you something to do. Okay. Now, I want to also do a problem that I did in another class, and I forgot to do in this class. I want to do one of the quick review problems, and it's quick review number 5. And the reason why I want to do this is because it's on the exam. In fact, this almost exact problem is on the exam. No, I forgot to tell you. Guys, there's 10 problems on the multiple choice that are very similar from year to year to year. That's why they don't release them.
So we know some of the problems. We gotta
Okay, shh. What? Okay.
Google Glasses. They should just throw those on the test.
They would be restricted. I know what you're talking about. Do you see the new Google glasses?
Yeah, just glasses.
Yeah. Yeah, but how many thousands of dollars are they?
They're 1,500.
Okay. Okay, guys. Okay, shh. You guys, we got to get through this. Okay, shh. Guys. Everybody else is doing well. Okay. You guys, on the AP exam, we got to get through this. I got to show you these slope fields. But I want to go through this problem because they have problems like this on the AP exam. They will give you a differential equation, and they will say, of the 5, which might be a solution to the differential equation. No, you're not going to solve it. It's a solution to the you could solve it, but if they ask you, is this a solution to the differential equation? I haven't taught you how to solve that yet. So the only way to do it is to check it, just like you check a solution. You put this into the equation, and you're going to have to do it over here, and see if it makes a true sentence. So what is the derivative of y with respect to x? You know this. It's e to the x squared times what? Times the derivative of x squared. Guys, 2x. Yes, you do. Yes, you do. What if I have x plus 3 equals 2x minus 10, and I tell you x is equal to 0? You would put it in there, and you would put it in there. So, yes, it's an equation. I need to see if it makes it true. By the way, what's the derivative of 5? So the left side becomes this 2x e to the x squared, because that's the derivative. Is that equal to 2x times my y? The y is e to the x squared plus 5. That's the derivative of y, right? And I found my derivative right there. They're not equal. So is that a solution? No. And this is, by the way, when you do this, and you probably won't remember it, but when you get these exponentials, if they're adding something there, that's not right. It's not going to happen that way. If I had had a 5 in front, it would have worked. On 1 through 11, they're just asking you to check. So you substitute this back into the equation. This tells me I'm going to take the derivative of my function, and I'm going to put it in here, and I'm going to multiply that out. And you can see they're not equal. If I didn't have the 5, I'd be okay, wouldn't I? This is the slope. Yes, these will have the same slope. I think I'm answering your question right. So you really should go back and do some of those to make sure you understand what we mean by checking to see if a function is a solution to a differential equation. Well, now we're going to look at differential equations a little bit differently. Because I only taught you how to solve easy ones, not something like this. This is not, you don't know how to do this yet. We'll come back to it. That's 6-4. And you notice this is a short chapter. So we should finish through chapter 7, because there's only 3 sections there that we're doing. um, before spring break, with even extra time to spare, which would be to do some practice AP stuff. We need to start reviewing before spring break. Okay, so we're going to look at this, and we're going to skip this expiration. We're just going to go over here and do the cosine function. I am going to actually put a different graph in there because my graph is. They don't have any trig graphs. Yeah, it's just this is a little bit better graph. Okay, we know how to solve this, don't we? So dy is equal to cosine of x dx. Let's solve it first, and now we integrate. What is the antiderivative of the cosine? What's the antiderivative of the cosine? Sine. How do I know? Take the derivative. How do you know you factored a trinomial correctly? You multiply it back out. That's how you do it. This is what I do here, too. I mean, sometimes I just know, plus some constant. Okay, we know how to do that algebraically. We're going to look at this graphically, geometrically. This is saying this dy dx is the slope of the tangent line of the sine function. So I'm going to make a table of values, and I'm going to graph a little piece of the tangent line at each of these points. Well, maybe not all of them, but enough to do something. And actually, I kind of wish I hadn't put those numbers there, but that's okay. We're going to make this equal to, darn it. Nope, I'm going to go with what I had before. It's not the greatest, but that's okay. Yeah, we're going to make it work. This is 1, this is 2, this is 3, 4. Okay, so we're going to do a little table, and you have to know a little trig. So when x is 0 and y is 0, I start at the origin. Okay? You see, it's pretty easy if you pay attention. And I want to find the slope of the tangent line at the origin. Yes, we want to do our increments in terms of pi. Don't have to, but I don't know the values. So what's the cosine of 0? That's 1. So at that ordered pair, 0, 0, I will draw just a little tiny piece of the tangent line. The tangent line goes on forever. We know that. But I just want the little piece. You guys, you've seen slope fields. If you watch the weather, you ever watch the weather maps and they show the little arrows of the systems coming through? That's a direction field. This is a direction field. If you all played with the magnets and you put a piece of paper down on the metal filings, it's been a while probably, and then the little filings all go in directions because of the magnetism. So you've seen slope fields, direction fields before. We're using this to guide us. So Jake says, why don't we use multiples of pi? So what's the next value you'd like to use? Pi. Now, let's just do this on the x-axis right now. Let's let the y be 0. Because guess what I have to do? I have to do this for a whole bunch of stuff. What's the cosine of pi? Negative 1. So at pi, I'm going to make this pi over 2, and this is pi, and my slope is going to be a negative 1 then. Well, after you get the hang of it, you won't have to write tables. You get no points in the exam for your table. Oh. Okay. Yeah. What's another nice one? How about pi over 2? Cosine of pi over 2 is what? It's 0. Okay, I should probably be in a different color. So this is 0 at that point. What's another missing? What's halfway between 0 and pi over 2? Pi over 4. Okay, now the question is, do you know what the cosine of pi over 4 is? What is it? Excellent. It's 1 over the square root of 2. And before the exam, I will review all those triangles with you. And so you get that into your head about what to do. Because on the exam, you're going to want to, you're going to, I don't know why I keep doing this. You're going to want to write them down right away. Okay, so I don't know what that is, though. Do you know what? You probably don't even know what the square root of 2 is.
I don't. It's like 1.2 something.
It's 1.414. Now, why do I know it? Because it's used in carpentry, and any carpenter will tell you what the square root of 2 is.
But you're a carpenter.
No. But I build things. Not well. You didn't ask me to do it well. Okay, so this ends up being the square root of 2 over 2. And you guys rationalizing the denominator. Now I need it. I needed it back when I was in school because we had slide rules, and I should bring one in, and you couldn't divide by a irrational number. You couldn't do it. So you had to rationalize it. Well, so now we really don't need that anymore, but I would like to know approximately what this decimal is. And my calculator I can't get to. So I know this is 1.414. We'll just do 1.4 because you can't get that close on the estimates anyway. So it's 0.7, a little less than 1, right? Okay, so at pi over 4, I'm going to have something not quite as steep as that. Now, how about 3 pi over 4? Do you remember the little rule about all students take calc? These are the trig functions that are positive. So 3 pi over 4 is in the second quadrant. The sign is positive, but the cosine is. So that's negative 0.7. I'm not going to write it in my table because I don't care. Okay. Now, does it matter what the y-coordinate is? The slope is equal to the cosine of the x-coordinate. So if I said the x is 0 and the y is 1, what's the slope there? It's the cosine of x. What's the cosine of 0? So guess what? It doesn't matter what the y is. When the x is 0, the slope is always 1. So this is a special case when you only have one variable there, and I can't remember if this is the autonomous one. What about here? This is not going to depend on the cosine curve, the y-coordinate. This is going to be 0.7. Oops, I didn't want to put that one there. And then at pi over 2, all these slopes are going to be 0. Well, I'll put it there. I didn't want to put it there either. It doesn't matter. I can put it all the points. And then this one's going to be negative 0.7. Are you starting to see, I hope, a curve there? And at pi, it's going to be negative 1. Now, everything depends. Remember, the answer is plus c. It depends on where you start for your particular solution. I'm going to start at the origin. This points me in the right direction. Slope is doing this. It's getting less steep. And when I get up to pi over 2, slope is going to be 0. Points me over here. And I'm going to be pointed back down. And there it is. And if you were to continue this, you would have a what curve? Sine curve. And then, what does the c do to my sine curve? Well, that's so weird, but okay. It goes up. Yeah. That's all the c does. Still stay the same. So if you look at your packet, and let's look at page 2 in your packet. Turn your packet. Well, I'll show you. Do you want to see that on the graphing calculator? It's my time. I got time. Hang on. I'll show it to you. Because those are where the trig functions are positive. All the other ones are negative there. Okay, so I'm going to clear my draw. Okay, now we're going to go into, I have this program. I can give this to you. You don't have it. No. We're going to do slope field, but let me show you quickly the Riemann sum because that's kind of cool. Oh, yes. No, I didn't. We'll do x squared. Well, I could. This would bother, I would get some bored typing all this stuff in. How many rectangles would you like to put under y equals x squared? Jack, how many? Well, let's do smaller so we can see them. Oh, okay. 6. I like to have a few more. That's what the partitions are. Okay, there comes my y equals x squared. And then I'm going to press enter. And you said 6, but I have to decide which kind of rectangles you want. Left?
I want midpoint.
Midpoint. Okay. Isn't that cool? Did it? I didn't touch it. Okay, we'll do this. You want to see left. Oh, I know. There's the left. Okay, how about more rectangles? So we have to, by the way, the definite integral will give you the whole thing. Okay? And it gives you the answer. And unfortunately, the only way out of this is to quit. Now, this stays running, you guys. When you have a program running, it stays running. If I press enter, it's going to come back up again. But I don't want that program. I want my slope field. And so let's look at the cosine curve. Now, this is dy dx. I want to put in cosine of x. I'm only at the first quadrant, but I can fix that. Am I not in the right mode? That one's a little harder to see, but let me fix my window. Let's zoom it. Trig. Now, nothing's showing up because it cleared the draw, but let's run it again. I'm just going to press enter. And it's cosine of x. This should be better. Now you'll see it. Now the problem is my calculator is missing, so I can't give you the programs today. If I can borrow a calculator from a BC student for a day or something like that, then I could actually give them to you, which would be nice. If you want it. This one's not too hard. No, it's not. I had to put it onto mine. And then I have to quit. I think I have to break. No, I guess I don't have to break out of the loop. We will come back to that. Let's do the homework problem. Well, no, let's do y equals. Let's do this. First, let me get a graph. So let's do this one. dy dx is equal to y. No x's in it this time. So here's x, y, and dy dx equals what? Okay, so you guys make a little grid or whatever. When x is 0, I don't care, but and y is 0, what's the slope there? Okay, guys, we don't have much time.
0.
It's 0. So it's 0, 0, I have 0. Now, when x is 1 and y is 0, what's the slope? No, the slope is equal to y. It's 0. The voice a little bit off. When x is 2 and y is 0, what's the slope?
0.
0. So it's 0 all the way across on the x-axis. Yes. They're not. You just take the ordered pair here. So if I take this ordered pair, which is x equal to 0 and y is equal to 1, then this slope is 1. I take all the ordered pairs. So, but notice that this is the same all the way across because there's no x in there. Okay? 2 is going to be steeper. Do I need a table? No. Yeah, 3 will be steeper yet. Yeah, 6, even 4 is incredibly steep. By the way, this is the second problem on the homework, except it says 2y, but it's the same difference. What if y is negative? So at negative 1, this is going to be a negative 1. Yes, it does. And negative 2 is going to be steeper, but negative. Whoops. And this is going to get steeper yet. I'm trying to make it steeper. Not so easy, but okay. You got the idea. If I start here, do you recognize this? It looks like e to the x, and it is e to the x. We will learn how to solve that equation, and you will see that differential equation on the exam, and that's a 100% guarantee. That's one of those 10 they get to you on those multiple choice. No, it's either the 2x, I believe. And notice that we can shift this, but it's going to be a little different when I shift it, so I don't even think I want to do it. So this is y equals e to the x. I don't know what that is. What is this one? What's the equation for that one? Negative e to the x. Okay? Now let's do the homework problem, number 3, on the worksheet, the white one. Yep. Because this one's tough. But actually, I do like this grid a little better, so I'm going to do this one. Especially on this one. Okay. This one I'm going to need a table until I figure out what's going on. It doesn't matter because there's plenty. Okay.
I feel like I have my brush on.
dy dx is equal to the sum of the x and the y coordinates. By the way, we are not going to learn how to solve this one. I know how to do it using techniques of differential equations, but we aren't going to know how to do this. So what we did yesterday, you guys, is we algebraically solved it. Today we're just looking at the solutions graphically. I'm not solving it. I'm just graphing the slope of the little tangent line. So here's x and here's y. And if I add them up, that's my slope. So at 0, 0, it's 0. Now I'm going to have to do all the points because there's an x and a y. When x is 0 and y is 1. When x is 0 and y is 2. 2. Okay. What if it's 1, 1?
2.
Now, are there any points that might be interesting?
Negative 1.
Negative 1 and 1.
Oh.
What about 1 and negative 1?
0.
And 2 and negative 2?
0.
And negative 2 and 2? 0. Good, let's plot some of these. Now, once you see it, do you have to show me a table? No, I don't require it.
Yeah, I got it.
And this is kind of fun. We have not had one of these on the AP exam in several years. Not on the free response. It would be. And we would have it with a differential equation. I would guess that that's probably going to happen. Okay, at 0, 1, the slope is 1. At 0, 2, the slope is 2. So it's getting steeper as I move up the x-axis, the y-axis, sorry. Now, the point in question was this negative 1 and positive 1. And then we had 1 and negative 1. And what about negative 2 and positive 2? This is going to move along a diagonal. See that? Well, what are you going to do here, though? Now, when y is 0 and x is 1, this is 1, 2, 3. It's getting steeper. How about 1, 1? 2, 3. Okay, so you get the idea of what you're going to do here. So let me get my calculator and see what it really looks like. Because it's an interesting little graph, but my problem is I got to get to it. And I don't know, see if I can borrow a calculator for next week. Or I have another option here. I just thought of it. If anybody's borrowed my calculator, because I don't know when it disappeared. Okay, so we are going to, now the program's still running. Remember that. All I have to do is press enter. And there it comes. Now I'm going to give you some other programs. I'm going to give you ACT, and I wish I'd given it to you in the fall, because on the ACT program, it has some study stuff for the ACT. And then I have an AP Calc program, which is huge. It has everything you want to know about calc. You can bring it into the exam, but if you have to resort to that, you're not going to have time to take the exam. Somebody's going to do a little extra math this weekend. Okay, we want x plus y, so you type in x plus, and the y is down here. No, it's at 1. There it is. I think it's cool. I'm not seeing the zeros, so you know what I'm going to do? I'm going to zoom at 6. I'm not sure where I was before. And let's try that again. Unfortunately, I got to type it in again. That could be fixed with the programming. I want a better picture though. There it goes. I changed the window. Now you can. You couldn't before. So now the question is, what do the solutions look like? Guys, if I start here, I'm going to go up this way. If I start down here, this is pointing me down, but I still have this asymptote here, don't I? Okay, that answers another question on the packet.